In this video, you will learn about squares and square roots, as well as application of these concepts in the context of right triangles. So to begin, we need to compare the similarities and differences between squares and square roots. Now, when we say square, we're not talking about the shape necessarily. What we're talking about is when you square a number, meaning you take a number and multiply it by itself. So for example, here we have 0 squared, so that means the exponent is a 2, so 0 to the second power, which means 0 times 0, and 0 times 0 is just 0. Well, 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16, and etc. So when you square something, you're taking a number and multiplying it by itself. Square root is kind of the opposite of that. So for example, if I said find the square root of 0, what this means is what number squared gives me 0. So what number squared gives me 0? Well, what number would that be? That's going to be 0. So our answer to the square root of 0 would be 0, because 0 squared is 0. Okay, moving on to 1. If we do the square root of 1, we're asking what squared gives me 1. Well, what multiplied by itself gives me 1? That's going to be 1, right? Well, what if I did, let's say, the square root of 100? This means what number multiplied by itself gives me 100? Well, the answer is going to be 10, because 10 times 10, or 10 squared, gives me 100. All right, so let's try one more. Let's say the square root of 49. So what squared gives 49? Well, that's going to be 7, because 7 squared, or 7 times 7, is 49. So the square root is like the inverse, or the opposite, of squaring something. All right, let's do a little more practice with the concept of squaring and square root. So try to think through the answers before I tell you the answer. And if you need to pause the video along the way to see if you can get to it before me, make sure you do that. So here we have 7 squared. So what does that equal? Well, 7 squared means 7 times 7, which would equal 49. What about the square root of 100? We just did this one a moment ago. What squared gives you 100? Well, that's going to be 10, because 10 squared, or 10 times 10, is 100. What about 12 squared? Well, 12 squared is 12 times 12, which is 144. All right, what about the square root of 36? Well, what squared gives 36? That's going to be 6, because 6 times 6, or 6 squared, is 36. What about 9 squared? Well, 9 squared is 9 times 9, which would be 81. What about the square root of 64? So what squared gives 64? Well, that's going to be 8, because 8 times 8 is 64. 8 squared is 64. All right, what about 10 squared? Well, 10 squared is 10 times 10, which is 100. So the answer is 100. And then what about the square root of 25? So you're thinking through what squared gives 25, or what multiplied by itself is 25, and that's going to be 5, because 5 squared, or 5 times 5, is 25. So make sure you know how to answer questions like this that involve squaring or taking the square root of a number. Now, one of many applications of the concept of squaring and square rooting is in geometry, and more specifically, it is with right triangles. So we have what is called a Pythagorean theorem, which is a theorem, or a rule, I guess, that works only with right triangles. And what it is it's a relationship between the different side lanes, and we can use this relationship to find an unknown side. The Pythagorean theorem, as stated, would be c squared equals a squared plus b squared. Now, what do these letters mean? Well, here we see a right triangle. All right, so we have one side length is 3, another side length is 4, and then this side length over here is unknown. We'll call that x. Now, these letters in the formula represent different sides of a right triangle. The main one to be aware of is C. This letter C is always what is called the hypotenuse of the triangle. The hypotenuse is the side opposite the right angle. So in this particular picture, the hypotenuse is over here. It's across from the right angle, so that is your hypotenuse. All right, and the other two sides, the 3 and the 4, are what are called legs. And the legs are going to be your a and b value in the formula. Now, the hypotenuse is not always on the right side, but it's always going to be across from the right angle and will always be the longest side. All right, so what we can do is we can use this formula and we can plug in the numbers to find this missing side length. All right, so using the same example, we have our formula, c squared equals a squared plus b squared. We said c is the hypotenuse, which is over here, right? So this is your c value. And then 3 and 4 would be like your a and b. It doesn't matter if 4 is a and 3 is b, or 3 is a and 4 is b. It doesn't matter as long as c is always the hypotenuse. All right, so what I do is I plug in these numbers. So in place of a, I put the 3. In place of the b, I put the 4. And the c is what we're trying to find. It doesn't matter if we choose the letter c or x or whatever letter. Either way, it's unknown. We don't know what it is. We'll just put an x in there because that's what's in the picture. All right, so here we have a little equation that we can solve. All right, so 3 squared would be what? Well, 3 squared is 3 times 3, which is 9. And then what about 4 squared? Well, 4 squared is 4 times 4, which is 16. So what is 9 plus 16? Well, that's going to be 25. So what we have here is some unknown number called x being squared that equals 25. So what squared is 25? Well, that's got to be 5, right? Because 5 squared, or 5 times 5, is 25. So x, or the hypotenuse, is going to be 5. And by the way, another way of thinking of this, from x squared equals 25 to the final answer, yes, you are asking what squared is 25, or another way of thinking of this is what is the square root of 25, which is the same thing, right? Because square root is asking what squared gives me 25. That's what square root means. So either way, our solution for this missing side length is going to be 5. Let's try one more example. Here we have this right triangle with side lengths of 6 and 8. We're trying to find this missing side length over here. So again, we can use Pythagorean theorem, which works for any right triangle. And our Pythagorean theorem says that c squared equals a squared plus b squared. Now again, when you're using this formula, make sure you plug in the numbers in the correct place. So c is always the hypotenuse, which is always across from this right angle. So this picture, again, the hypotenuse will be over here. And that's going to be your c value. And then a and b would be the 6 and the 8. It's a and b. So we plug those numbers in. So a is 6, so 6 squared. B is 8, so we have 8 squared. And then c is unknown, that was x. We'll just leave x in there. So we have x squared. Now from here we can solve. So 6 squared is 6 times 6, or 36. 8 squared is 8 times 8, or 64. So we have 36 plus 64, that gives 100. So the question is, what squared, some number squared, equals 100? Well, what would that be? That's going to be 10, because 10 squared is 100. The other way of thinking of that would be, what is the square root of 100? So again, the square root of 100 is asking what squared gives me 100, which is what we have up here stated with the x squared equals 100. So either way, our solution is 10. That is the length of this hypotenuse for this triangle. So 10, and the units are feet, so it's going to be 10 feet. So these are the, I guess, more basic types of problems you will see. If you have some weird numbers, like something that's not a perfect square, like for example, if you had like x squared equals 101 or 110, something that's not a perfect square, you still can find the answer, but you'd want a calculator to do that. So on your calculator, let's say you had x squared equals 105, your answer is the square root of 105. All right, so on your calculator, you'd have to type in the square root of 105 to get your answer, which would be some decimal number. And then also, as you progress in your study of mathematics, we could use the same formula to find maybe a leg instead of a hypotenuse. But for this lesson, we're just trying to find the hypotenuse, but you could use some other more advanced math to find the leg if needed as well. And that concludes our lesson for today. We will see you next time.